We're now going to do example 2 of the 7E videos. And what we're going to do here is we're going to write the equation in vertex form for the functions in example 1. Now I'm going to come, this is actually B. I'm going to actually do B here for you. And in order to do it, I had to go ahead and write what the vertex is. Now when I check this in class, I'm going to expect to see your work over here to come up with this. So vertex form, remember, would be that y is going to be equal to a times x minus the x value of the vertex, which is 3 squared, and then the y value, which is going to be minus 9. Now I have one more thing I need to replace, and that's going to be easy because this a in this problem is the same as this a is right here. So for this, a is going to be equal to 2. So I'm going to put a 2 and then x minus 3 squared minus 9. So here is our equation in vertex form. Now you try this one, try A, and see what you come up with. We'll now take a look at a third form, which is called the factored form of a quadratic function. So we're just going to do a little investigation here first. I have x squared minus 2x minus 3, which is going to perhaps be different than what you've got. So I'm going to factor this to solve it, to figure the solutions there for where x is 0. So in this, I'm going to look for two numbers that multiply to be negative 3 and add to be negative 2. And I'm going to have x minus 3 and x plus 1 multiplies to be negative 3, adds to be negative 2. Then I'll have x minus 3 is 0, so x is 3. X plus 1 is 0, so x is negative 1. So these are going to be my solutions. Then to the right, I have graphed y equals x squared minus 2x minus 3. And what I want you to notice is that the x-intercepts for this, so on this, the x-intercepts are negative 1 and 3. So they are the same as our solutions. So the x-intercepts are the solutions to the quadratic equation set equal to 0. And our factored form of a quadratic function will look like this. The solutions, I said the same thing here, of a quadratic equation set equal to 0, also called the roots are zeros of the function. Zeros because they're the solutions when we set it equal to 0. The roots or zeros are called the R1 and the R2. So these are my solutions, and they're also the coordinates of the x-intercepts, R1 and R2. So to graph a quadratic function written in factored form, we're going to plot, when it's written in factored form, we can look and see the two x-intercepts. So we're going to plot those on the graph. Then we're going to use symmetry to determine the axis of symmetry, and then we're going to find and plot the vertex. So I'm going to swing over to the next page and do that now. So for example 4, which says graph the following quadratic functions, notice that they're written in this factored form. So here's my factored form. So I can look and see that R1 is equal to 4 and R2 is equal to 6. So that means that these are my x-intercepts. So I'll just put x-intercepts here. So we'll put those on our graph. So we just have a 4 and a negative. This should have been a negative 6 right there. So I have a negative 6 here and a 4, 1, 2, 3, 4 right there. So those are my x-intercepts. Now I'm going to use symmetry to figure out the axis of symmetry. So it looks like it was folding up there. So I'm going to kind of come in 1, 1, 1, 1, 1. So I'm getting this here, negative 1, to be my axis of symmetry. Double check it once you do that and make sure 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that is the middle. So x equals negative 1 is the axis of symmetry, just by looking and seeing the middle. So then once I have that, then I know that my vertex will begin with -1 for the x value. So I'm going to then calculate what y is. So y then is equal to -1/2 times x, which in this case is -1 minus 4, and x, which again was -1 plus 6. So y is going to be equal to -1/2. This is going to be a -5, and -1, and this was plus 6, is going to be a +5. So y then is going to be equal to negative times negative is going to be +25 over 2, which is about, what, 12.5? So we probably want to use that when we graph it. I'll write 25 over 2 there because it's smaller. So 12.5, which is going to go off, here's 10. Looks like that's going to go off my graph here. So up high, I'm just going to put it way up there. All right, so then maybe another point. Let's do the 0. So let's figure out what's going to happen when the x is equal to 0, which is going to be the y-intercept. If we get that y is equal to -1/2 times 0 minus 4 and 0 plus 6. So that's going to be a -4 times 6 is -24, and times a -1/2 is going to be +12. That's not going to give us a lot of help, is it? So it's just going to be really close up here. So we'll just do this. And here then is my graph. Not so pretty, but there it is. Right there. So we will take a look at B next time, and why don't you try C and just give it a try and see what kind of questions you come up with. But remember, try means to try, not to say I don't understand. So go back, look at the steps, do your best to come up with an answer and a graph on that.